So we're going to do a little lesson review on the number e and how we use it and how to do calculations with it on your calculator. So e, what is e? Well, e is a number that's roughly 2.7188281828459045, etc., etc., etc. And it's called Euler's number. It's pronounced Euler. Euler is a mathematician, did lots of fun and amazing stuff. For what it's worth, E, if we take this relationship, 1 plus 1 over n to the n, as n gets really, 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 really big and goes to infinity, this relationship goes to roughly E. So if we look on your calculator, and I do 1 plus 1 divided by, let's say, 1 plus 1 over a trillion raised to the trillionth power, that equals 2.7182818828. Now you're thinking, well, Jeff, that's all well and good, but how am I ever going to remember this number? Well, here's how. There's this guy, Andrew Jackson. Andrew Jackson. And he was a U.S. president. He happened to be the 7th president. He served 2 terms. First elected in 1828. Since he lived in the old Wild West, the story goes that on either side of his 90-centimeter waist, he carried a 45. So 45, 90, 45. So that's how you can remember that number. Anyway, where we'll use this number is when we're doing continuous compounding of interest. So looking at your calculator, how do we calculate using E? Well, here's a key, ln, just for natural logarithm. Then right above it here is e to the x. So if I do second function e to the x, and I put in an exponent, so this is e raised to the first power, that's 2.7182818828. E to the third, second function, x, that's e cubed equals something or another. E to the 0.0267 power equals 1.027. Okay? So we'll see equations where we're solving using E. So for example, let's say I invest $10,000 at 4.5% continuously compounded interest. How long until I have $75,000? So using our continuous compounded interest formula, we've got 10,000 e to the 0.045, that's the interest rate, t equals 75,000. So we're solving for t here. So how long will it take? How we solve this problem, Divide by 10,000 on both sides. So e to the 0.045 t equals 7.5. Now we don't have algebraically a way to solve for t when it's the variable. So what we do is we take the natural logarithm on both sides, and that may or may not mean anything to you, but that's what we do. And then we find, so how this side simplifies is simply to that exponent. Now I divide by 0.045 to get t by itself. So t equals the natural logarithm of 7.5 over 0.045. And if we use our calculator, we have ln 7.5 divided by 0.045 equals 44.7756. That's 756. That means in about 45 years, your money will turn from $10,000 into $75,000. Or actually my money, sorry. And I'm not sharing. How can we check this? Well, we check it simply by 10,000 e to the 0.045 times 44.7756. And that should equal roughly $75,000. So 10,000 times second function, e to the x, 0.045 times 44.7756, and that equals $74,999.92. So close. Because we rounded, it's not exactly 75,000, but that's pretty darn close. So that's E. That's how you use it on your calculator, and that's how you solve equations involving E.